Let's see some word problems. Let's see 69. Eric has 5 coins in his pocket, and the total is $0.95. The coins are either quarters or dimes, right? So we know dimes, each one is 10 cents, 0.1, 10 cents. And quarters are 0.25, 25 cents. So how many each? So how many of each type? Let's see, he has D many dimes and Q many quarters. So together, that's 5 in total, right? Because of 5 coins. So D many dimes and Q many quarters, as together is 5 coins in total. Now, so this is one equation. Now we can make another equation from the money, right? So total, she has 95 cents. And how much from dime? We know each dime is 10 cents. And he has D money. So that's 0.1 times D, right? Each dime was 10 cents. The D money multiplied by 10 cents. That's the money from dimes. So similarly from quarters, each quarter is $0.25 or 25 cents. How many he has? Q money. So Q money multiplied by 25 cents. That's the money amount for quarters. Now we have 2 equations, 2 variables. We have formed a system of linear equations. So we just have to solve. So how do we solve this? I don't like to, deal with decimals. So I want to multiply my second equation with 100. Because $1 equals to 100 cents. So basically, I want to change the notation of dollars into cents. In that case, I get 10 cents times D plus 25 cents times Q. That equals to 95 cents in total. So the first equation, I have D plus Q equals to 5. You see, the second one, I can simplify it, right? If I want to simplify, I can simplify the second one. But we don't really have to do that. I can solve this equation by doing this, by multiply every term with 10 for the first equation. So I enlarge every term, 3 terms, 10 times bigger. Now I want to do subtraction. 10D, subtract 10D, that becomes 0. 10Q, subtract 25Q. Well, we can do this one. We can call this one second one. We can use 1, subtract 2. So 25Q minus 10Q, that's 15Q. 95, subtract 50, get 45. Now we divide by 15 on both sides. So 45 divided by 15, that's 3. So Eric has 3 quarters. Well, if Q equals to 3, what's D? D equals to 5 minus 3, because he has total 5 coins, 2. So the equation, the solution for the system equation is dime is 2, Q is 3. So to answer the questions, see, Eric has 2 dimes and 3 quarters in his pocket. Now let's see 70. A particular brand of fruit juice contains 2 gallons of orange juice for every 7 gallons of pineapple juice. Right? All right. So this is like a ratio. The company that makes the fruit juice has 82 gallons of pineapple juice. How many gallons of orange juice does a company need to make a batch of this juice? So this is a ratio problem. This is in 2 gallons of orange juice, right? Orange juice to 7 gallons of pineapple juice. So this is ratio in between those 2 different kinds of juice. Now, this ratio has to be kept. Now they have 82 pineapple juice. That's corresponding to how many orange juice, right? So let's call this X many. We have a fraction on the left-hand side. We have a fraction on the right-hand side. We can do something called a cross multiplication. Like this, like a half equals to 3/6. How do we prove this is true? 1 times 6 is 6. 2 times 3 is 6. 6 equals 6. We call this cross multiplication. This only can happen when we have one fraction on the left-hand side, one fraction on the right-hand side. Okay. So now we have one fraction, 2/7 on the left-hand side. We have x over 82 on the right-hand side. So we can do cross multiplication. So we do x times 7, which is 7x, equals to 2 times 82. We divide by 7 on both sides. So 2 times 82, that's 164, divided by 7. Because this application is not pure math. If it's pure math, we can just leave this. But now we want to find out how many gallons of orange juice. So we need to do approximately. So 164 divided by 7. We could do long division. 164 divided by 7. 2, 14, 24, 3. 3 times 7, 21, 3. So if we answer 23, that's not enough, right? Because we have this remainder of 3. So which means we want to round to 24. So we need a 24, about how many 20? What about 24 gallons of orange juice? Okay, to mix a batch. Now let's see 71. The tickets to a play cost $9 for adults and $5 for children. If the show sold 180 tickets and earned $1,380, so how many of each type of tickets was sold? So how many? So let's call adults A many for adults and C many for children. So A many for adults, C many for children tickets, and total is 180 tickets. Now for the money amount, each adult costs $9. So the money from adults is $98. And 5 for each children. So 5 times C many children, that's the money from children. And together, that's $1,380. We have system of equations. So we need to solve this. Right, to solve this, maybe we multiply 5. Maybe we get rid of C. To get rid of C, we want to multiply 5 with every number in the first equation. Then we do subtraction. Right, let's call this 1. Let's call this 2. We use 1 minus 2. 9a minus 5a, we get 4a. 5c minus 5c, that's going to become 0. So 1,380 minus 180 times 5. Well, that's 900, right? That's 800. 5 times 8, 30. Then 1 times 5, so that's 800. Well, 1,380 minus 800, how much? That's 580, isn't it? So divided by 4 on both sides. So A equals to 580 divided by 4. Well, 580 divided by 4, let's see if we can divide it evenly. Yes, we could, right? Can we? 5, that's 1. Then we have 18. 18, we can do 4. 4 times 4, 16. We have 20, 145. So 145 adults. Then for children, we have 180 in total minus 145, which is 35 children. So to answer the question, we see how many, so 145 tickets sold for adults and the 35 tickets sold for children. Okay, one more. Let me erase all this. Lift this up. This is the last question. 72 is saying Katie has done 6 more than twice the number of math problems Tommy has done. Okay, so together they have done 72 math problems. So how many math problems has each student done? Okay, let's call Katie done K many. Let's call Tom done T many. So Tom has done T many, right? So what's the relationship between K and T? So Katie has done 6 more than twice the number Tom has done. How many Tom has done? T many. So K equals 2T plus 6. T represents how many math questions Tommy has done. K represents how many questions Katie has done. So Katie has done 6 more than twice of Tommy's. So that means K equals 2T plus 6. And together, that means K plus T. They finish 72 questions. So we have this system equation. And I have showed you elimination method, but this one I'm going to do substitution because the K is already here. So I just have to substitute this K into this, right? So instead, so I'm changing the second equation as writing K as 2T plus 6, then plus T equals to 72. 2T plus T, that's 3T. Then I move 6 to the other side, becomes negative, right? So 72 minus 6, that's a 66. Then I divide it by 3 on both sides. So T equals to 66 divided by 3, which is 22. So Tommy has done 22 math questions. And what about K? We go back to K. K equals to 2 times Tommy's plus 6 more. That's a 44. 2 times 22, that's 44. Plus 6, that's 50 many. Okay, so Katie has done 50 math questions, and Tommy has done 22 math questions.